All right, testing 1, 2, 3. All right, testing 1, 2, 3. Hello, Morningstar. What's up? I'm just gonna wait for a little bit until people start joining on the live stream. All right. So I'm just gonna wait a little bit before I can start the tutorial. So as you can see, what we have right now is just this one. Are we going to create the structure for the animations today? If the time permits, yes. I think when we get to the part where we're gonna have to place those animations, we're gonna have to make the structure. Maybe today we can make the structure for placing the animations. Sorry, well, we're only going to make the structure in the part that's really needed. All right, let's go. Hello, Hikmat. Since there are only project files on Patreon, not tutorials, does that mean that we will never see a tutorial for the cornering and freehang part of the system? I can make the tutorial for that, but generally, people who get the premium project files, they're not really, they don't really need the full tutorial. They just need to know where the systems are placed, how they can change that, and how it was done. They're just worried about this. It's a different public, I think. But of course, there's the other part beginners who are willing to get the most out of the project. But if that's a request, then I can make it a tutorial for that, for the cornering and the freehang and also the leap 180 and also the climb up on top. All right. So let's continue. So now what we have in here is just the ability for the character to, you know, hang on the ledge. But now, as you can see, I can still be able to move the character, and we're going to fix that one. So if I press the WASD keys, I can still be able to move the character. So let's just fix that real quick. So in here, as you can see, we have the movement input and the hands input action IA move. Let me just debug to see what's happening here. All right. So here we're going to do a simple branch, and then we're going to get the IsAlreadyClimbing ledge. So only if the character is climbing on the ledge, only if the character is not climbing on the ledge, we can run the default code. So if the character is climbing on the ledge, I'm pressing WASD keys and the character is not moving anymore. So that's now the problem is now fixed. He's very inside the box. We're going to fix that issue later. If that is combined with the climb on top of the box turret, then that would be great. Yeah, it would be. I think Morningstar is the only one who wants this tutorial. Because I don't see anywhere anyone else asking for the tutorial of the standard system. Standard. All right, so the next thing we're going to do, we're going to calculate the differences of, we're going to calculate the current and target location. Actually, we're not going to calculate anything. We're going to just save the references of where the character is currently and where the character should be. So we're going to get the actor location, and then we're going to set the current location. And then here we're going to check, we're going to set the target location in here. And then in here, as you can see, we're going to get the hang trace, the hit result structure. Now in here, we only want to get the impact point to be placed in here. Now here we're going to do some calculations to basically set so that the character, basically what we're making here is just the correction of where the character needs to be on the target. So We're going to do some offsets in here just to place the character where the character needs to be. So we have a variable that we've created. It's called LedgeForwardOffset. I'm going to get it, and then there is also LedgeVerticalOffset. We're going to get it as well. And in here, we're going to get the actor up vector. Multiply, and then if you just drag and drop the input pin in here, as you can see, it turns green. So that we can use it in here. What else? Now we're going to get the actor forward vector. I think that's it. There we go. There's only 2 people watching this stream, really? On Saturday. Maybe everyone is enjoying their time with the family, as I was. So to make this compact, we're going to just select everything, collapse your nodes, and then we're going to place it here. Now inside that collapse graph, as you can see, we have these calculations in here. And for the default value for the ledge vertical offset, it's going to be -25. For the ledge forward offset, it's going to be -25 as well, maybe. Now, these values are going to depend on which character, which skeletal mesh you have, okay? So if you have a different skeletal mesh, probably your character has different arm sizes. So you might influence on the vertical or forward offset. So just make sure that the default value matches. I'm going to show you later how it works, but basically if you find that the character is floating on the ledge, yeah, or the character is going inside the box, for example, then you need to change those variables in here. So this one changes the forward offset and this changes the vertical one. Now you can also choose to change the horizontal mode, but it's not really needed as the impact point gives us the exact point where it was hit. So the character is going to go to that direction. Let me just copy and paste those informations in here. So this is the attach location. Now, as we're going to be running timelines on the right way in here, on the right side, we need to basically update the states of the timeline before it runs. So I'm just going to drag and drop this one over here. Rotation, timeline finished. Now here on those spaces, we're going to use two timelines, one for setting the character's location and the other one is for the rotation. Hello Enoch, what's up? How are you guys doing? There is seven people watching the stream. Do some of you are interested in the Ledge system or not? Interested in learning blueprints or not? Interested? Are you interested? So as we're going to have two timelines, we're going to make one in here. So we're going to add a new timeline. Now make sure to rename your timeline so that it's easier for you to access it later. So let's say, for example, you want to stop that specific timeline, so you know by name which one you want to stop or execute or start. So I'm going to name this one to be location timeline first attachment, because as soon as you press F, then that's the first attachment, that's the first hang action that you're going to do. And then so what I'm going to do here is just duplicate this timeline in here. Just make sure that you have the values already set up before that. So I'm just going to create a new float value. The new track name, you can choose which one you want it to be. I just leave it as it is right now, default name. The length is going to be like how many seconds it is going to take for the character to correct its position on the ledge. So when you press on play in here, as you can see, the character is going to attach himself on the ledge. And then this amount of seconds is the amount of seconds that it takes for the character to fully correct its position to be fully attached on the ledge, on the location that you want. So what I'm going to do here is just set the length to be 22 milliseconds. I think that's enough time to make the character to smoothly attach on the ledge. And now what I'm going to do is just add a new key for the curve, two keys actually. And the first one is going to be, for the time is going to be 0. The value is also going to be 0. And then the last one is going to be, the time is going to be 22 milliseconds. And the value is going to be 1 as a value. So if you press F, as you can see, you can zoom in. So now that the first timeline is set up, we're just going to copy paste. Alex Fire, what's up? Alex Fire 367. Let me just copy this name in here. So basically you're going to just duplicate this timeline in here. You don't need to recreate everything from scratch again. Now this one is going to be rotation instead of location. All right. Very nice. Now we're going to do the location first, and then we can do the rotation. All right. So here, before executing these timelines, as we're going to be executing these timelines at the same time, we can get a sequence so that I can execute them at the same time. So then one is going to be from plugged into the play from start. Then 0 is going to be placed in here. So we're going to get the current, we're going to get the current location of the character, and also get the target location. Now in here, as we want to lerp those values, we're going to use the lerp node. So we're going to use the lerp vector. And then the alpha value is going to be connected into here from the timeline. And then in here, after update, we're going to set the actor location. And then finally connect into here. And that's it. Now it's going to work. As you can see over there. I think the character is too much down. His hands are too much down. Let me see if I can fix that through here. Attach location, vertical offset. Click here. Sometimes it glitches, as you can see when you click on the float. It gives you the details of the rotation timeline. So all you gotta do is just compile, save maybe, and then click on it again. Sometimes it glitches on the engine. So as I want the character to be a little bit up, I just need to change this value here. So instead of -25, I'm going to choose it to be just 20, just to see how. I think it's just going to be too much up. No, maybe not. We can choose a value to be -16 or 17. So as you can see, it's already fixed. Yeah, I think this value is good. It's very good. As you can see now, you just need to do this once for each character. Of course, if you change characters, if you change characters at runtime, maybe you're going to need this to be dynamically set, but I think nobody's going to change the characters. The skeletal meshes, it's going to keep changing them. So you just need to change this value once for each character. Now, if you start using another character, you might change this value to another number. Now, the forward offset, it changes the forward offset. So if you do a value like 2 instead of -38, as you can see, the character is going to be too much to the inside the cube, so we don't want that. So let's keep it 38 negative. All right, now all we gotta do is just update the location timeline on the finished event. Now I'm going to get the 2 booleans, timeline finished. So I'm going to get the location and rotation timelines. And pay attention that the default value of these timelines of these booleans are true. Or is it true? I'm not sure. No. Yeah, I think they could be true because as the timelines are not finished, I mean, when you play the game, the timelines are not really, they don't get to be executed as soon as you play the game. So I think it makes more sense to let them to be true. But I'm going to let them to be false right now because as I'm not having any problems with that, I'm going to keep the way it is, just to not have headaches later. Now this one has to be true because we're just finishing up the timeline of the location. So make sure that the timeline, the finished execution, matches with the type of translation you wanna notify that has finished. So this is location and this is rotation. So this is the location timeline and this is the location timeline for the boolean. That's for the boolean. Now we're going to do the same thing for the rotation. But in here, let me just get the can attach to ledge to be true, because as soon as the timeline finishes, we want to update some events. So we want to allow the character to be able to attach to the ledge again, as soon as he wants, as long as he wants. So now here we're going to set the actor rotation. Now in here we're going to use a Lerp Rotator. In here we're going to use a Lerp Vector. So they're different. But both, they do pretty much the same thing. But for the Lerp Rotator, you have this an option here called shortest path. So depending on the difference, that the result is, the function is going to automatically choose what's the shortest path in order for the character to face a certain angle. Otherwise, you could get some bugs like seeing your character to do unexpected, not needed yeah, I think this option is just to make your character to face the target angle that you want in a smart form, in a smart way. But I'm not using this option right now because I'm not having any issues. But if I start seeing issues that the character is rotating too much or is snapping, something like this, I'm gonna take a look at the rotation timeline. If the character's rotation is snapping, now if the character's location is snapping, we're going to take a look at this code in here or this code in here, just to make sure that everything is running well. All right, so now we finished our execution. So let's see if the character is now rotating to face the angle when we attach to the ledge. I think I forgot. I've done something wrong in here. Let me just unplug the rotation timeline to see what's happening. Okay. Yeah, I'm not sure. Maybe it's the attach location that is wrong. Let me check it out. Hello, Steve. What's up? Yeah, guys, I'm placing the wrong location. Instead of connecting the actor rotation on B, I'm connecting it into A. Huh, that's why. 24-hour stream part 2. Maybe. So to fix this issue, just connect the get actor rotation to B, because that's basically getting the current actor rotation, which means the current character rotation. And then for the A, we need to plug in into Z the current ledge angle. So let's just play that. There we go. Now let's try to get into a different angle, like this one. Yeah, I'm not sure why it's doing that. No idea. Maybe it's because I'm strafing. Could be. As you can see, it's getting the wrong location. Trying to think what it is. 24 hours of stream. Well, I think it could be because of the root motion, maybe. Because I think all the calculations seems to be right. Maybe it's because of the root motion somewhere. Let's check out what animation is being played in here. So we have this animation. Yeah. I'm just forced to root lock. Yeah, that didn't work. Let's see, the current ledge angle is 0. Tag is 0. Now the tags are right, but it's not working somehow. Okay. Maybe that's the issue. We don't have any value on the vertical offset in here. Maybe that's why. Oh, I think it's glitched again. So let me just compile save. Okay, so now we have the values. So here is negative 32 and here's negative 16. Yeah, I'm not sure how to fix this one. This one got me. How much experience do you have with Unreal Engine? 3 years, maybe 3 years and a half, we could say. 3 years. Sometimes you do the same thing, the same code. It's basically the same code as I've done in here. But this one works and the other one doesn't work. Incredibly enough. Let me just try to do without animations. Without this animation in here. Let's just play the character on the T-pose to see what happens. So, boop. Okay. Let's try it this way. As you can see, it's not the animation itself, so it's probably something else, some other value. It's not. It's not it. Do you think I could build a mobile game with it that I can run smooth 60 frames? Yeah, I'm not sure. It's going to depend on your skills, on your skill set, very much. Now, I've never made a mobile game, never worked with mobile, so I'm not sure how difficult it is compared to making a game for Windows. Let me just check the timelines. Okay, the timelines, the time is 22, the value is 1, which is working great. Here's the same thing because I duplicated it. So we set the actual rotation in here, location, right above. Update the states. Yeah, I don't know. I don't know this one. This one got me. This probably isn't the problem, but I remember from the last stream you added the node get reference, not get a copy log, setting the F current ledge angle available. This one. Yeah, let me just check and debug this value here. Which value am I getting for the ledge angle? Because this should be 0. That one should be 0. So as you can see, it's 0. But then if I get from this angle right here, it gets to be 0, but the character gets to be set on a different direction. Let me get the shortest path to see if I get something else. No. Yeah, that's weird. Let me just try to do that same thing if I do that same thing in here. Yeah, I also get that bug. Incredibly enough. Let me just open up the already built system to see if that bug happens, because maybe that bug already happens on the default code. On the even on the premium, I think I've just discovered a new bug on the project by myself. So I'm just going to open it up and let's see. Did you beat The Last of Us 2 yet? How did you like the story? I like the story pretty good. The story is pretty good. A lot of I've heard a lot of people ask, not ask but hate the story. I think the story was good, but if I did beat, yes, I beat the I've already beat the game. And I always play the other mode that has like the Last of Us modes. There is the survival mode. This one. The mode that has the, yeah, I think it's called roguelike mode. This mode, I always play it. It's very good. So basically you cannot die. If you die, you reset and come back from the beginning. So there's a lot of levels and there's a lot of maps. And basically, if you survive on the first map, you can choose which one you can go for the next one. So for example, here you've just completed the challenge. So you can choose which map you want to choose to go. And then if you die on this one, and then you're going to, if you die on this one of these ones, you're going to reset back to the first map and then just keep, just going to reset everything. But it's very good until you reach it into the final boss, which is after all those ones. It's very good. I play on the hardcore mode. This probably isn't the problem. This probably isn't the problem, but I remember from the last stream you added the node get the reference while setting the f current ledge angle variable. Let me just see if I have the... Let me just place the first hang attachment in here. Hang attach ledge hang ledge as well. So let's try it out. Okay, now let's get this to be... Yeah, this one doesn't have bugs. That's really interesting. Okay, yeah. It also happens on the standard. As you can see, if I'm aiming this way and then I attach on the ledge, the character goes through the block. Maybe I've deleted some code that shouldn't be supposed to be deleted. So I'm gonna have to compare and do that on the stream. Added the node get a reference and not get a copy. Okay, got it. So this is get a reference, right? So if you get from the tags, this is a array, as we could have multiple names into a single tag. We could get, and then we have a option to get a reference and then get a copy. Now, when you get a copy, the node looks like this, but when you get a reference, you get a node that looks like this one. I'm not sure what's the difference. If you guys know, let me know. Between getting a reference and then getting a copy. But I usually use the get a copy instead. Let me see if I got a copy in here. Oh yeah, I got I got the reference because I was doing things very fast. So let me just get the copy instead and then press on play. But I think it's going to be the same because, you know, it's the same mode, it's the same value that I got from before. So this is not going to be the final boss. Maybe. Okay, let me just. Take a look here. Copy creates a separate independent version of the data. Changes to the copy do not affect the original. Reference provides direct access to the original data. Changes to the reference directly modify the what? Copy creates the separate independent version of the data. Changes to the copy do not affect the original. Reference provides direct access to the original data. Changes to the reference directly modify to the original. Yeah, I did understand that, but maybe the copy, the copy is more performant and the reference is less performant. All right. Uh, 40, 49. Wait, what? Wait, what? Yeah, I'm not sure how to fix this one. This one is going to be very tough for fixing. Can process input. Okay, let me see if there is something related to the rotation of the character. That's weird. It's weird because like when you go forward, the character attaches perfectly. But then if you're aiming to the left, why is that? Okay, let me do the following. I'm just going to go ahead and copy. I'm just going to basically copy all the code from the premium system because it works, and then try to do the rest. Try to see if it works. All right, let's try to see if it works. Now it works. Now the problem is fixed. Now the problem is fixed, but now the animation is not playing. Let me just find the animation. It's hang idle UFN. This one. No. Hang UFN. Hang catch. Yeah, entry. So let's just play the animation and then try again. Now it works, but what's the difference? I think the only difference here is just this coding here. Determine if the character will play a support or freehang animation. Yeah, I think it doesn't matter as well. Let's just compare the difference and then see which code we've missed, which is very important. Let's see. What is it that's changed? So let's start from the beginning. All right, so here we have the can process input, hang trace attachment, which is the same thing. It's not going to change much. We have the same trace, capsule trace for objects, and then capsule trace for objects. Now here we do the set the do second step climb to false. Can attach to ledge, flying, the stop movement ability, max fly speed is 0. Set collision enabled to 0. Here's true. Already climbing ledge. Do second step climb. Can process input. Then here have a lot. It's very much the same thing. And then here you have the v current location to store the location of the character. And here we have the calculation to make the attachment of the character in there. And then in here, we follow up the code. Now the timelines are also correct. SetActorLocation, the lerp goes there. The target is B, the current is A. So current location is A and the target is B, as it is right now. Everything seems to be correct. Current into Z, A. Character actor rotation into B. Everything seems to be all right. It's the same code. What? Wait, what? Let's change the... Let's just replace this one with the code that I've done from scratch. Yeah, that's weird. Well, if it works, it works. What can I say? It's the same code. Let's try to change the trace now. To see. You want by repetition, never before thought possible. Still doesn't work for us. Really? But it worked for me. But it works for me. Well. You want by repetition. Can you guys see that? It's just the same code, but one works and the other one doesn't work because of nothing. Nothing. Mesh, capsule, character movement. Now if I try this one. The only difference in here is that we set the character rotation. We set the character rotation in here, which is really not needed in this code. Let's try that. Yeah, that's it. That's the actor rotation. Fixes bugs. No, that's the so yeah. So then we need the set actor rotation then to prevent bugs. Now it's not happening, but if I remove the set actor rotation, can you believe that one? There you go. That's the fix. That's the fix. It took me like 30 minutes to find out. Because usually when we don't need to set the active rotation, as we're going to set the active rotation here. But as we're making calculations, as we make calculations before, wait, yeah. So first we set the active rotation, which is going to set the capsule rotation of the character. It's just going to set the capsule rotation. Let me just show you guys what I mean real quick. So use the flip-flop and then set time dilation. So time dilation here is going to be .2, and then here is going to be 1. So that when you press 1, the character goes slow motion. Ooh. So when let me just try to not hide the capsule. As you can see, the capsule of the character is represented with this sphere 1. And as you can see, it's moving because the motion matching, the way gas is set up, the gas project is set up, the capsule always move for doing the strafing. So as soon as you attach the character and press F, as you can see, the capsule, it gets attached, it gets rotated actually to the same. As you can see, the character is right over here. Press F. As you can see, the capsule instantly gets rotated to face the ledge. And then as soon as the capsule gets rotated, we calculate where the character needs to be at, because now that the capsule is rotated to face the angle, we just need to calculate where to place the forward and the vertical axis, the vertical position of where the character needs to be at on the ledge. Maybe it makes sense. Now, if you try to put it before or after the calculation, I think it's not going to do any good. Yeah, it's not gonna do good. So yeah, that's the fix. All right, so now we're going to work on the detach phase. Now we're going to work on the detach phase. So as you can see, now the character is fully is attaching on the ledge properly. Now we want to detach the character from the ledge because we need to make that movement as well. It's like making a car. If you can only accelerate but you cannot brake, then the car is useless. That makes sense. If the car doesn't have brakes, then it's useless, right? so let's make the detach phase. So if you agree with me, it's okay. Now for the detach phase system, we're going to disable the setIsAlreadyClimbing because this variable tells us if the character is currently climbing or not. So it's very important to have this variable set up. Now, as we have the variables, the timelines properly set up in here, we can just search for that variable. This is for the location, this is for the rotation. So we're going to get those sort of reference variables. Now we're going to paste them in here, stop, and then we're going to stop those two timelines. And then we're going to prepare the movement to detach again. Just make this a little bit up. Prepare a character for detaching. So I'm going to copy paste these two nodes in here. Now the character is going to be walking again or falling. You could either choose walking or falling. Both works. I think both works for this purpose. Now in here we're going to get the collision enabled back, and then in here again we can set the can process input to unblock player movement. Now here you're going to get this, we're going to set can attach to ledge, and then here you're going to stop all timelines. Actually, we don't have that event yet, so don't worry about this, because at the end in here we're going to stop all the timelines that are responsible for correcting the character's position while for ledge navigation. That is when the character is going up, down, left, right, you know, those ledge navigations, we use timelines to correct the position of them. So we need to stop the timelines in the detach at the end of the detach function. So detach, remember to not detach, but stop all the ledge navigation timelines. There we go, emojis. Now after that, we're going to get SetActorLocation timeline finished. True. Now let's test it out. Oh yeah, I forgot to set this to be true. And set this to be true as well. So as soon as the player detaches from the ledge, we're going to allow the player to move normally again on the ground. So we need to take this option to be true and be able to attach the ledge again if the character wants, if the player wants. All right. Now the easiest part is done. Now this is the easiest part. This is the easiest, very easy. Now we're going to do and dive up a little bit into the complex part, the medium to complex part right now. Right now we cannot navigate to the ledges. That's what we're going to try to do in the next second, which is right now. Yeah, too easy. Too much easy. This is the easy stuff. Now we're going to make the navigation on the ledge. Let me just prepare this prepare the map a little bit. All right. All right, now we're going to make the ledge navigation system, which is basically if you use the WASD keys for, you're going to make it so that you can use the WASD keys to navigate in the ledges, right? So what we're going to do is go to the event graph. We're going to use the input keys, the values that goes -1, 0. You're going to get what I mean. So here on the event graph, you're going to find the ER move. So what we're gonna do in this action value in here, it gives you two input values. One for going, it receives inputs. Actually, this, how can I explain this? So this is a structure value, and then it gives you two inputs, one X and one X and one Y. So if I break the vector, you're going to have X and then Y. Now X is when you move W. So when you press W, this X is the X value is like 1. And then if you press S on the keyboard to maybe go back, to make the character to go back when you're walking, it gives you -1. So if you press W, the X equals to 1. And then if you press S to go backwards, the x is going to equal -1. So +1 or -1 depending on which direction you go, forward or backwards. Now for the y is the same thing for going to the left, but for going to the left for going to the left or right. So it gives you -1 or +1 as well, or vice versa. Yeah, I'm gonna show you what I mean. Just print the string and see with your own eyes what I mean. So when you press, why it's not showing? It's because you have to get the, I don't know, something like action or input. Yeah, get movement input scale value. So then you can break it. And then let's get the x. I don't know which one the x represents. Oh yeah, the x represents the direction going left or right. So if you press left, as you can see, it's -1. Press right is +1. Now the y is for going forward. So if you go forward, it's +1. If you go negative, if you go backwards, it's -1. All right. So now, as long as if you understand that, let's go for the next part. So I'm going to promote this to a variable because I'm going to be referencing it inside the code. I'm going to actually I'm not sure if I have that variable yet already. I think no. So I'm going to name this variable to be v2, which stands for vector 2D. 2D is because it has 2 directions. And then movement input. Here we're gonna have to create a macro. But first, before creating a macro, we're gonna have to separate them into 2, because as long as you release when you release actually if you release all the directional keys, we're going to execute this canceled event in here. This execution is going to be triggered. Both the cancel and completed, or one of the 2. I don't remember which one is going to be executed when you release all the movement input keys. So we're going to create a macro. This macro is going to be named such as action values. So here we're going to create a new macro. Macro name is action values management macro. I'm just going to paste some comments in here. Don't worry about them. Just to facilitate the tutorial. Facilitate. Now here we're going to get the can process input. We're going to get a branch. And then here we're going to block the inputs if false. We're going to have to add execution pin to the inputs, and actually 2. The first one is going to be called triggered. The second one is going to be called canceled completed. Now we're going to create a variable, a new float variable. If you don't have it right now, we're going to have to create it. It's going to be called f action value x, the first one. The other one is action value y. I need to refine those. Oops. Here, just to make sure that we reset the values to back to 0 in case we release one of the directional keys. Actually, all the directional keys. So we're going to get our V2 movement input. We're going to get its movement, get movement input scale value. We're going to split the structure. And then in here, we're going to get the F input X and Y, Y and X. Now, don't ask me why. Don't ask me why I've done this. It just works. But basically, it's for making it to work on the gamepad as well. So it just works. I've made the round function to be in here because I thought the values. I think the round function makes it to work more smoothly. So yeah. But the comments are here. This blueprint checks if the player can move. If not, it forces movement inputs to be 0, so that we don't have any bugs, glitches. If yes, it reads the real inputs, stores them, then rechecks them. X-axis is clamped into digital steps, -1, 0, 1. Y-axis stays smooth. So we're going to drag and drop the macro in here. Of course, we're going to have a output execution pin as well. I should get a second monitor to follow along. Now, after I've done those changes, I think nothing much is going to change. It's just that the inputs are now handled in the way that it needs to be set, in the way that it needs to be handled to work with, to make a smooth ledge navigation to work with both keyboard and gamepad, if you have one. Now we're going to just collapse everything into a collapse into graph, but first I want to just get this one to be connected into here so that we can collapse this into a graph, and then default movement. All right, we're going to create a function called LedgeTraceDetection, which is going to serve as for detecting the ledges while navigating into them. So for navigating on the ledges with a 2D possibilities, which is be able to move up, down, left, right, we're going to use a single trace, which is the capsule trace for objects. So we're going to get the capsule trace for objects. Now this is where the medium to complex part gets, which is to get the function of calculation for the LedgeNavigation. So we're going to create a new function called CalculationForLedgeNavigation. I think I'm not gonna do everything from scratch. I think I can just copy the code that I have in here so that you guys can follow. And then I can explain how I've done it. Remember to make that calculation as a pure function. Now in here, for placing this, for basically setting up the location, knowing where the location of the trace should be at when you move the directional sticks, directional input keys. Could be the WASD keyboard on the keyboard, the WASD keys on the keyboard, or it could be the analog stick on the gamepad. It's going to work. So what we basically do, we get the actor location as a base. We get the actor up vector. And this, we have the Z offset up and Z offset down. So this controls the Z offset of the capsule trace. We're gonna have to do this code as well. Get this code. Z offset up is 56, 65, 65 for the offset down. What do I have to say about this code? It basically checks if the player is pressing W or S so that you can basically place the trace where it needs to be. And that's basically all that this code is doing. You can change these values to see which one works the best for you. But I've already refined it in a way that it works very much good for the ledge system that I have. The radius on here is going to be 30. I think it's a good radius. The height of the capsule is going to be 40. Now you can, for the drag debug type, you can choose to be for 1 frame, because this is going to be executed on the event, on tick every frame. So we're going to just drag and drop that LedgeTraceDetection there. Press play to see what's going to happen. So as you can see now, when you press the directional keys, and you're going really fast, could you go through the calculation for the LedgeNavigation function again? Sure. Which part do you want to see? Yeah, so for the Z offset up, you have 65. For the Z offset down, you have 65 as well. And then inside that collapse graph, you have this code in here. So it basically selects the float, but I think it's not really needed to do this. But if you want to modify, yeah, there could be a more optimized version of this one, but you can pretty much follow the same code. Doesn't matter. because those values here are the same, 65, 65, it doesn't make sense to make the code to choose which one, if he wants 65 or he wants 65. So I think it doesn't make sense. As I was testing a lot of values to see which one works the best, and based on the inputs, and then based on this and that and this and that, I've just let the code to be this way. All right. Now, as you can see, when you press the directional keys on the keyboard, you're going to be able to see that you have the control. Let me get my gamepad controller to see if I'm able to also control the inputs. All right. So as you can see now, I'm using my gamepad controller. And it works. Now this return node in here is used for finishing the function, so you always add that. Now we're going to set the LedgeHitDetected. Set it to be true, depending on the condition of the trace. Here we're going to set the dynamic. I'm not sure if I have that variable already. No, I don't. So I'm just going to promote this to a variable and call this to be dynamic ledge attach. Get ledge hit detected. And place this in here, ledge hit detected. So this function is going to tell us if the ledge was if the ledge was detected when you navigate in the ledges. It's going to tell us if the ledge was detected. And then here you're going to get the branch. And then I think for the next tutorial, we're going to make this part for the ledge climb movement, which is the hardest part, the final part. So as you can see right here, I have a already made version on my side. I'm just following up. So as you can see on this collapse graph, we have the whole core of the code as well. And then it checks, it does a lot of checks to basically calculate where the character needs to be, where the character is, what's the condition, determines which direction the character should go, which animation should be played, how the animation should be played, how the character should be corrected on the transition, how the what speed, what distance, which angle, which animation, the method of translation, the speed of the animation, the starting position, how the delay until correction. So like how long does it take for the character to correct its position on each animation based on the parameter value. And yeah, that's going to be for the next tutorial. Yeah, so that's going to be it. And in the next tutorial, I'm going to see you there. It's going to be tutorial part 3. And yeah, that's going to be it. I see you guys later.